coordinates if you like as well, or for things like point clouds, but it generally finds its major use case in geospatial visualization. At its core, it's about declaratively creating visualization layers from some kind of data set. And we have a rich layer collection, so you can basically use the same data set and just swap and change layers. And one of its key strengths is that we use the GPU, so the graphics processing unit, in the web browser to accelerate. So even though it runs within a website, it can actually handle quite a lot of data. So often people get into using deck.gl because they start doing something with maybe leaflet, and that works fine for a few points. Then they maybe switch to maplibre, and that's working fine for more points. But if they really want to kind of visualize a lot of data, then they go to deck.gl. So this is what some of the visualizations from deck.gl look like. This is just taken directly from the website. So it's all the kind of usual stuff that you would expect, like scatter plots, heat maps, but also some more kind of interactive layers where the GPU rendering really does make a difference. So you can kind of like interact with the map, and the animation is going to be super smooth because it's the GPU that's doing the calculations. Just a quick intro to the API to give you an idea of what you can do, because this is a powerful framework, but we try and make it easy to use. So essentially, the deck.gl API is going to take some kind of data, generally in some kind of like list format. So here it's just JSON. And it's going to map this using a set of functions that we call accessors, which basically tell deck.gl what to do with every kind of point in, or every kind of like feature in this data set. So here it's just as simple as saying that my position is going to come from the coordinates, which was the first one here. And then the fill color is just going to look at the type. And if it's major, it's going to draw red. So these values here are RGB. It was written by nerds, so rather than using real CSS colors, we like to see 0 to 255. And if it's not major, it's going to be 000, which is black, which ends up looking something like this. Okay, so this talk is not meant to be an intro to deck.gl. It's more kind of what's new, and hopefully we have some time for questions afterwards, so I can kind of get an idea from you what you'd like to either see in deck.gl or what you'd like to learn about deck.gl. So when I say deck.gl, it's not actually just one project anymore. It's kind of the well-known project that got started at Uber maybe 8 or so years ago. But around it, there's a whole ecosystem of other projects which kind of come under this VizGL umbrella. But that's not as a recognizable name, so I called the talk deck.gl State of the Union. But of course, like all of us in this community are working on a bunch of related projects. So one of the projects that you might have heard here of is Kepler-GL, which is a full web application built on top of deck.gl that lets you kind of drag and drop data sets and configure them using a UI rather than using the code. And then we have a whole list of other packages here that are either kind of sub-modules of what deck.gl is using. So an example here is loaders.gl, which lets you load all sorts of different data into deck.gl. Then we have math.gl, which unsurprisingly is providing some kind of math functions. And some of our very popular frameworks are the base map modules. So the ones at the bottom, the ones for Mapbox, Maplibre, and Google Maps. These actually are getting more downloads than deck.gl itself now, because they provide a very, very nice way of having one of these base maps in a React application and not have to worry about kind of how to plug it into this reactive workflow. Maybe good to touch on a specific point of people sometimes ask me, like, how does deck.gl relate to these other libraries? Like, how is it different from maplibre? And here I would say, well, first of all, we have a really good collaboration with maplibre. We're not trying to operate in the same area. We're basically a visualization that sits on top of maplibre and is integrated in such a way so that you can't even tell that it's two libraries if you're a user. So if you just interact with the map, then the overlay that we are providing is so seamlessly integrated that it feels to the user like you have just one piece of software that you're working with. Okay, so the latest version is deck.gl 9.2, which came out about a month or so ago. It's been some time since any one of us has talked at FOSS4G, so I'm kind of going to do the best selection of new features going a little way back. So not all of these are new in 9.2. The first one, I think if you went to Yuri's talk on maplibre, then you would have already seen this. Maplibre has got a nice new GlobeView, which lets you see the world as a globe, as it is. We have integrated with this in deck.gl, and this is really nice for certain types of data sets, especially kind of global ones where you don't want to have the distortion that you have with the Web Mercator projection. The really nice thing that we have here is a particular type of support for what we call interleaving, where the layers that we're drawing into the context of maplibre are actually inside the 3D space that is the same one that maplibre has. So this means that here in the GlobeView, if you kind of have like a flight that goes behind the planet, it's not drawn in front of the planet, but it's kind of like obscured by it. And the same is true if you zoom into a city and you have a layer of like buildings and they're 3D, then your lines are going to be going in between and behind them. So it really gives this like sense of depth for the user. So here I'm just going to switch to a little demo. This is the map that we have on the website for maplibre. And to kind of explain this interleaving concept, then I can turn off the interleaving on the labels, and you kind of see that they would end up behind the textual visualization, which is really not what you want to do. Let me just switch to another example that is using this GlobeView. This is one with the global grids. This takes a little bit to load. Obviously, a really nice example of where having a globe makes sense, because if you try and display these on a Web Mercator projection, then the hexagons or whatever cells you have just completely blow up near the poles. The next big feature that we've been working on is one that's very kind of invisible, but very important, which is porting the library to WebGPU. So there is some support in most browsers nowadays for WebGPU. It's not always on by default, but it is on by default in Chrome. And we've been trying to basically port the whole framework to WebGPU, but in a way that provides back compatibility. We don't want you guys to have to break your applications just because we've made this transition. And this is actually quite a challenge because the two APIs are very different. So in general, WebGPU is like a completely different API. It gives you some performance benefits. I wouldn't expect it to be like 10x. It's more useful because it gives you different ways that you can do more interesting computations on the GPU. So for me, the exciting reason to do this is more to get things like compute shaders available in the browser, so we don't have to kind of hack around the WebGL way, which often means you kind of have to encode your data into a texture and sort of pretend that you're rendering to an image, and not actually having the compute capabilities that actually GPUs have supported for maybe, I don't know, 10 plus years. We've been doing this process step by step. I think I'm going to skip over this because it's maybe a little bit too technical, and just show you that we already have a preview enabled in 9.2. If you want to use WebGPU, then you basically tell deck.gl when it's starting up, I would like a WebGPU adapter. That's what we call it. And then it's just going to render using that. Now, the caveat here is that it doesn't support all of the layers. We only have 3 at the moment. So there's the point cloud layer. I mean, spoilers, it's the easy layers to port, but you have to start somewhere. So the point cloud layer, then we have the scatter plot layer. So as I switch between this on the website, it's just going to re-render it with WebGPU. Not the most interesting demo. I'm just showing you the examples we've had for like 8 years and saying, hey, check it out. It's definitely WebGPU underneath the covers. So, but yeah, pretty happy that we've got to this stage where we're actually drawing something, and hopefully we can follow fast with all the other layers. Okay, a really, maybe not like difficult computer science problem, but exciting feature for the ecosystem is widgets. So deck.gl was always focused very much on just the visualization, but most of the time when someone wants to build even the most simple app, they want to have some kind of interactivity, like something as simple as a button to zoom in and out. And in the past, this meant that they would have to basically take deck.gl and some kind of framework like React and build an application. And it's actually kind of complicated if you're not a JavaScript developer to be like, okay, so now should I use React or should I use Next.js, and what does all of this mean, and what does it mean to build something? It kind of made it much more difficult to make like simple applications. So we have added a whole kind of suite of widgets to deck.gl, which you can include in a declarative way. And they're aimed to make it really easy to do some of the kind of simple tasks. So if you look at the example in the top right, then it's just a standard deck.gl application. But you're not just specifying layers, you're also going to be specifying a set of widgets. And you just tell deck.gl that you want these, and it's going to sort everything out for you. It's going to make it responsive. You can specify the placement, like top left, bottom right, all of this kind of stuff. It's going to make sure they're not going to overlap, and so on. And the widgets themselves are written in React, and I'll actually show you later how you can make one yourself or extend some of the ones that we have. So just a quick spin through some of the widgets that we have. There's one that you can use to reset the view. One which is useful for these non-geospatial use cases, this gimbal that shows you what your current orientation is in your data so you don't get lost. Probably my favorite is the splitter widget, which lets you render two views at the same time and kind of sort of resize them. Related to this is just like a view selector widget, which lets you just swap between different views. A scale widget, a geocoder widget, an info widget, which is basically like a pop-up, and a couple of simple utility widgets, so taking a screenshot, changing the theme, an FPS widget, etc. Now, these things might not seem so exciting, but the number of times someone has come to me and asked, like, how do I make a loading indicator, and I then have to spend 20 minutes giving them a demo or something like that, is quite frequent. And then having something that can just be dropped in, I think, is very useful. Likewise, this kind of timeline widget is something that often in deck.gl you want to scrub through your data, you want to have some kind of filter. And conceptually, it's easy to do in deck.gl. It's just a question of how do I build the UI? And if you're a JavaScript developer, then it's easy. But if you're not, then that actually might be what stops you using deck.gl and means that you'll pick up another framework instead, which is a shame. So I'll just do a quick demo of some of these widgets. This is actually a test application that we have on the deck.gl repo, not on the website. So if you want to kind of play around with this, you can look at the code there. So we have, just as you'd expect, a zoom in widget, this compass widget, full screen, taking a screenshot, an FPS that's probably a bit small for you to see. This is the one that jumps you back to the original position. This is the loading widget here, because the layer we have here is a WMS layer, so it's kind of loading in the background, so now that's stopped. The dark mode, and here is the multi-view system. This in particular is something which I think is not so easy for people to implement, and it really lets you make quite a rich application in a declarative way. And it's nice to notice that the widgets are not just defined on a kind of global level, but they're attached to a specific view. So you can quite easily make some kind of, let's just zoom into, let's see if I can remember where New Zealand is. Yay, okay. Yeah, so the widgets are basically defined per view, which makes it really kind of easy to build a complex application without having to kind of be an expert in React. So if you want to make your own widgets, we expose exactly the same API that we are using, and we're trying to make it like very, very simple. we are using Preact, which is like a very small kind of React-like library to define the HTML. And we provide this abstract class that you can extend and implement a couple of methods. And these kind of get fed into the widget lifecycle and then can be used in the application. So we have all of this in our documentation. But briefly, there's just like a bunch of methods that get called on setup. So when you're creating the initial element, you need to implement this function called onCreateRootElement. And then you get these callbacks from the library, like onAdd, onRemove. Hopefully, it's all quite sort of self-explanatory. And if you have a good idea for a widget, then please contribute it. I think this is actually a very nice place that people can get involved in the ecosystem, because it's not something that requires deep understanding of the kind of rendering library, but it's something which is kind of making your life easier, and it might make the life easier for someone else. So this is just an example of how the not first person widget, frames per second widget is implemented. So you can see it really isn't very much code. It's just like explaining how you'd like to render something. We have a few small little helper components that can help you, like the icon button, so you don't have to reinvent it yourself. And yeah, that's pretty much it. So the widgets are also available in PyDeck, and this is actually quite interesting because it gives you a way of adding user interface elements in places where deck.gl is being used as like a rendering engine. I think technically this would be possible in Longboard as well, but I'm not sure if it has been done. But Kyle is shaking his head. I guess that means I'm going to do it by next year. Yeah, so that was basically everything for deck.gl. Just briefly, in Kepler.gl, there's actually been quite a lot of new features after a few years of not so much development. So there is now an AI assistant, which lets you kind of talk and explore your map. DuckDB has been integrated, and there is some WMS and raster tile support. And lastly, then I just want to point out these sort of map wrapping libraries have really been getting quite a lot of downloads. Naturally, people are not only using these with deck.gl, but it's really nice to see that this kind of like model, or this API that we've come up with for wrapping these completely different libraries is getting a lot of popularity. And it means that as a developer, it's easy for you to switch from, say, Mapbox to Maplibre and keep more or less the same API. But not just that, you can also switch to Google Maps and keep more or less the same API, which is really, really nice, because if you develop an application with, say, Google Maps and someone says, hey, let's try Mapbox instead, and that means rewriting everything, then you're not going to do it. And I think this makes it much easier for developers to plug and play and try different map providers, and all at the same time having the visualization on top of them be implemented by deck.gl, so you don't have to port it to like a whole new framework, so say from like Google to Maplibre. And the React Google Maps is something that's a library that's only been out for, I think, 2 years now, and we're already up to 500,000 weekly downloads, which I think is pretty incredible. Just a quick mention of our deck.gl community repo. So in general, a lot of people rely on deck.gl as a framework, so we have to be careful not to break things. So we kind of split out some modules into deck.gl community. In particular, a very useful one here is the editable layers, which provides support for drawing on the map. A lot of people are using this. But in general, if you have some useful layers that you would like to share with other people, then feel free to come to this repo. Like here, we're very open to merging and sharing new things because it's not deemed as kind of part of the core library. And if some of these things become kind of very popular, then it's a good way to kind of stage it and make its way into the main module eventually. Okay, so I'm running a bit low on time. I would just do a quick shout out to point you guys at our summits. So we've had every year now for 4 years a summit which alternates between the EU and the US. Next year we're planning for Zurich, probably in September. And we'd really welcome talks from the community. So the summit is 2 days long. The first day is the maintainers, basically talking about the new features, but the second day is the users. And we have a really interesting, just wide set of talks. Like this year we had people from Google, we had someone working on medical imaging. Like it's really quite interesting. We have the talks recorded online, so we understand that not everyone can travel halfway across the world for what is maybe quite a niche summit. But we do our best to upload these talks because I think a really great output of these summits is the kind of actual videos and the talks that people are giving. So the talks for the previous year are online. As you can see, Chris is working on the talks for this year, but he's demanding to have his Thanksgiving dinner before he actually uploads them. Yeah, so I would just finish on saying, like, it'd be great if you guys could get involved. You can reach us. The best is through Slack. We're actually part of the OpenJS Foundation, so you'd need to go on the Slack there, or just on our GitHub, which is github.com/visgl. Okay, that's everything. Are there any questions?
Hello. Hi, Felix. Thanks for the talk. I was curious about, it seems like there's a lot of work that's done for the integration between maplibre or other map libraries and deck.gl. And I'm wondering, is there a point at which the features that you are going to look to develop with deck.gl ends and then the other libraries begin? Like, is there some things that you don't plan on implementing in libraries like deck.gl because you know that other map libraries are taking care of that?
Yeah, so there would be the kind of classic, like, base map rendering things. So, like, wanting to have text that can go along a line, which is something very, very useful for labeling a map, but is not so much for, like, data visualization. So I think that's one where we don't want to try and duplicate. I mean, we have an MVT layer, so you can get the same layers and load them into deck.gl, but you don't have all the niceties of all the styling and all of that kind of stuff, which is actually very, very complicated to get right. So I think that would be the sort of main one where we wouldn't invest in it because we see that the base maps are doing it well already, so why duplicate that effort?
Thanks. I have a question about the 3D globe. Why, imagine you're a developer and you have a use case of using 2D or 3D data, 2D and 3D data. Why would you choose deck.gl versus Cesium, which is doing globe and 3D data very well and have solved some of the problems that you were talking about?
I mean, normally when I see Cesium, then it's kind of using raster imagery to render the globe. So it's more kind of like a virtual globe than a visualization framework. Whereas if you're using maplibre, then yes, you can have a raster layer, but it's more just trying to show something symbolically. So I think part of it is to do with the look. And then it really depends on what use case you have. Like both of the libraries are established and have lots and lots of different features. And if there's some feature in Cesium that is great for what you're doing, then that's sort of the perfect one to go with. And if it's one in deck.gl, then you'd go with deck.gl. So there's no kind of like quick and easy answer. I think I would just say try both. Cesium is a very impressive software library. So if it works for you, then great.
We probably have time for one more question, if anyone's got one. No? All right. Well, once again, please thank Felix for his great talk. And I certainly personally look forward to the next deck.gl.